Welcome to qnawire.
This is question 5.72. We have a 6 kilogram box sitting on a ramp that's inclined at 37 degrees. The coefficient of kinetic friction between the box and the ramp is 0.3. And we are told that a horizontal force is applied and the box is moving up the incline with a constant acceleration of 3.6 meters per second squared. So I've drawn the free body diagram here. We have this horizontal force being applied. The ramp, you can picture, is here. So friction is opposing the motion. So the friction is going to be pointed down towards the ramp. We have the weight of gravity pulling straight down. And then the normal force against the ramp will be perpendicular to the ramp. This is our N normal force. So let's first consider the forces that we have here. We have the force of friction. So let's explicitly write out that our friction force is going to be its kinetic friction since the box is moving. So it's going to be our coefficient of kinetic friction times the normal force. Now the normal force here, since we have two forces that are pushing on this block that are perpendicular here, or that are going to cause this force perpendicular to the ramp, we have to consider the normal force due to each of these components separately. So the normal force is going to have one component from gravity, from this weight force, and that's going to be mg times the cosine of theta here. We break this up into components perpendicular and parallel to the ramp. And then we're also going to have the component from this force. And if we do the same thing, we're going to get that the normal force from the horizontal force is F times sine of theta. So now we can find our total friction force by just plugging in to our normal force right here. So that's our friction force. So now we want to set up our Newton's second law equation. So we know that the sum of the forces is going to equal mass times acceleration. So let's think about all of the forces going up the ramp here, since we know that the acceleration is up the ramp. So we're going to consider this as the positive x direction. So we're going to have that component of the force will be F times cosine of theta. We'll have F cosine of theta. That's going to be the component of the force that's pushing up the ramp. Then we're going to have our friction force, which is opposing that. So minus our friction force, since that's pulling it down. Then we're also going to have gravity pulling down. So the component along the ramp there is going to be mg times sine of theta. So this is going to be our total force acting on this in the direction along the ramp, and that's equal to mass times acceleration. So now we want to solve this for F. So remember I'm going to, at this point, plug in our whole expression for our friction force, since there's an expression for, since we see F show up there. And let's, to simplify this, let's first distribute out this factor of mu k. So that's going to give us a minus mu k up front here. And now we can group the like terms together. So we want to get F on its own. So let's move all the other terms to the right side. So I'm going to add this to the right side. And I'm going to add this term to the right side. So we now have these two terms with F, so I can pull out the factor of F. That's going to leave cosine of theta minus mu k sine of theta. And so finally, to solve for F, we just want to divide both sides by this entire term here. So this looks like a pretty messy expression, but all of these are variables that we know. So we know that m is 6. We know the acceleration here is 3.6. Mu k is 0.3. G is 9.8. And theta is 37 degrees. So we can just plug in everything directly here. And when we do that, we should find F equal to 115 newtons.